Hi everyone. Today we will be discussing about service discovery concept. What is this service discovery? Why it is required? Where it will be used? If you have a microservice based architecture, you will be having multiple microservices. So how does these multiple microservices communicate with each other? How microservice 1 knows the endpoint of microservice 2 to get some functionality. It can be through RPC mechanisms, which includes sending API calls, request and get the response back, or it can be through protocol buffers, through some other mechanisms. But if you are using a HTTP request, you should know the network IP address and port of the other service from where you are trying to get the information from. Similarly, if you have clients which are interacting with your microservices, the client will get the functionality from the microservices through HTTP APIs, REST APIs. These HTTP calls will use the endpoints of the services. So these endpoints, how does the client know that this is the endpoint that I have to call, I have to use in my API signature? When you are having microservice based architecture, sometimes you will add extra microservice instances depending upon the load. Similarly, sometimes you might delete or deregister the existing microservice if the load is less. In that cases, how does the clients or whoever is using these microservices are aware of the endpoints of the existing services when there is a dynamic updation of the service instances? These use cases are solved using this concept called service discovery. So this is the diagram of the use cases where the services are interacted with each other, or the client is trying to interact with the services and services are getting added or deleted. So now what is the data that we want to satisfy the use case? We want the endpoints of the services so that clients can use those endpoints to get the functionality. So we can store these endpoints in a static file before starting our complete system and use those data key value pair. You can store it as a key or value pair, key and value pair, so that your key will be your service name and value can be your IP address and port of the respective service. We can store all this information of all the services in a static file before starting our system, microservice based system, and clients or other services can use that file whenever they require the endpoint of the service that they wanted to use. This is one method which is using the static file. But there are some disadvantages of using this method. What are those disadvantages? One is, as we discussed, it is a static mapping. So before starting of our system, we had this file. So all the entries in that file are static. But our services can get their IP addresses dynamically, and allocating the static IP addresses for the services upfront is a limitation. Similarly, and using this approach, the dynamic updates in the sense adding a new service instance or deleting the existing service instance is a little difficulty, because we have to update this file whenever a service is getting added or deleted. Since this is a static file, adding and deleting the new services is a limitation in this concept. So what is the other alternative that we have? Dynamically maintaining the whatever this file, or it can be a database which can be dynamically updated. Let us see that. Maintain the required data in a shared resource or a database or as a file, whatever it can be, that can be updated dynamically. In this service discovery concept, this data source is called service registry. Now we wanted to maintain this service registry. So to maintain this service registry, we need to have some access points to this service registry to add a new entries, to delete a new entries, to update the existing entries, to use the existing entries. So how this service registry will be getting updated? So what are the access interfaces or functions that this service registry should expose? And who are the stakeholders that will update this service registry? Where do we maintain this service registry? Whether it is an external component or internal, that we will be discussing in this. And who are the end users of this service registry, or how this service registry is getting used? So now let us go into the first question of how is this service registry will be updated. That means which are the functions or APIs that needs to be exposed by this service registry. We have to expose a functions to add a new entry. That will be done by the post request. We need to update this service registry at regular intervals so that the service registry will be having the entries of the microservices which are there in the system as of now. So for that we need to send some kind of heartbeat signal to this service registry. This will be done by sending the put or by exposing a put API that will be sent to the service registry at regular intervals. That regular interval timing can be decided by the system. It can be 30 seconds or it can be 1 minute, whatever be the, depending upon the system. Similarly, to deregister the existing microservice instance entry from the service registry, we need to have a delete API. These three APIs are for maintaining the entries within the service registry. Okay, now you maintaining all this service registry and values. Somebody has to use this. So for that, we will be having the GET API. Using this GET API, whoever wants, they will fetch the data from this service registry. So now we have the infrastructure like APIs post, put, delete and get APIs that are exposed by the service registry. Now somebody has to use these APIs to update the service registry. So that who is going to use this service registry to update the service registry? This can be done in two ways. One, the microservice itself can update the service registry. This is called self-registration. The other option is there will be a third-party service that checks the existing system for any changes. Here the changes means any new addition of the microservice or deletion of the microservice or change in the microservice network IP and address. So there will be a third party service which keeps checking all the services network addresses and updates the service registry accordingly. This is a other option. Now let us see what is the advantages, disadvantages of both methods, who is using these methods, and how the four APIs that we discussed earlier are getting used in these two cases. The following table will show you the information that we are planning to discuss right now. Now, the first, as we discussed, there should be a push method exposed by the service registry. In self mode, this push method is getting used by the microservice as soon as the microservice is registered into the system. As soon as the microservice is created, it sends a push signal to the service registry. And similarly, at every n seconds or n minutes, at every regular interval, the microservice itself will send a put API to the service registry to update its network addresses. And whenever it is getting deletion, that times it sends a delete signal to the service registry so that that entry can be deleted. All these operations will be done by the microservice. So who is going to use this kind of self-registration? By the way, this method is called push model or self-registration because the microservice itself is pushing the data. Netflix OSS Eureka client uses this kind of service registry updation where microservices itself maintains the code to update, delete or put the data. The advantages of this concept is it is simple in the sense there is no other extra component involved. Microservice itself will take care of updating the service registry. But the disadvantage is you need to have a framework or a code to update the service registry in your microservice implementation. That means generally the microservices can be in different languages even within one complete application or one big system. Some microservices can be in Go language, some can be in Python, some can be in Java, some can be in C, C++, or whatever be the language. Now we need to have this service registry updation logic in each and every service if we follow this concept. That means we can go for some kind of framework that is implemented in each language, and each microservice is going to use that framework in their implementation to update the service registry. This is a disadvantage because each and every microservice needs to have this code, and this framework needs to be implemented for each and every language. On the other hand, if we go for the third party service implementation, which is called pull model, because this extra service is going to pull the required data from the system by checking or tracking or getting the notifications from the system at regular intervals and update the service registry accordingly. So whenever it finds there is a new addition or new service, then it is going to send a push signal to the service registry, and it polls at regular intervals the existing system or existing microservices. It checks all the microservices and their network addresses, and if it sends the put signal if there is any change. Similarly, whenever there is a service deregisters, it sends a delete signal. So this extra component is generally called as service registrar. So this service registrar, it can be a router or it can be a API gateway or third party services, we can have a different names, but in general it is called a service registrar. Some of the guys who is implementing this concept is, there is an open source project called Registrar which implements this concept. Similarly, in Netflix there is another project which Netflix OSS Prana uses this concept, and you have Kubernetes, Amazon Load Balancer, ELB, Elastic Load Balancer. They have internally within the Kubernetes system and Amazon ELB, they implemented this third party service concept, and it is internally getting used. You need not have an extra service for this. Advantage of this method is it decouples the service registration logic from the microservice. So microservice need not worry about how to register, how to fetch, or how to send. All this logic is decoupled from the microservice implementation. No need of extra framework, which was the disadvantage in the case of self-registration. But one disadvantage here is, in some implementation other than Kubernetes and Amazon ELB, if you go for the Netflix OSS Prana or Registrar, or you have your own different system, you need to have one extra service that takes care of this logic. So you need to maintain that service, one more extra microservice. This is a disadvantage. Now we know that service registrar is there, and there are two methods too. update the service registry. But where is this service registry maintained? It can be maintained within the infrastructure itself. As I mentioned, in Kubernetes and Amazon ELB, it is part of the infrastructure itself, the service registry also. So there is no extra additional file or database or microservice. Or it can be an external. So internally maintained by Kubernetes and AWS, we will be having internal, and external there are couple of tools available: etcd, Console, Apache Zookeeper, Netflix. They are the external service registries. They use external service registry and they maintain that. Now you have the service registry, you have the entries, you need to use it. So how do you use it? Is it so simple that, okay, whenever you want to call some service, the client, assume that you have a client UI, you are trying to call some microservice called order inquiry or publisher inquiry or customer inquiry, some microservice for the information. So you know the microservice address, so in service registry is there, which has the information of what are the endpoints for these microservices. So who is going to use this service registry now? Is the client or the server? Because client is making a call, API call, so he should know where to call the API, the network address of the service. So is the client will get the network address and then sends the API directly to the service? Let us see. So there are two options here. Option 1, as I mentioned previously, client can talk to the service registry, get the network address of the service that it is going to talk, and form the API and call the service. That is option 1. Netflix uses this option. But what are the advantages and disadvantages of this option? In this option, as you already see, client is taking care of the service registry, it is owning the service registry at the client side. So he is talking to the client, and so he is the responsible to get the network address. So when he gets the network address, he is the responsible to send the API also to that. So let us see what are the advantages and disadvantages. Advantage is, it is simple. You directly make a call to the service registry, get the details of the service that you want to talk, and make the call. And your client is going to maintain the service registry. And one more advantage is, since client is making the call directly to the service instance, assume that you have 3 instances of a particular microservice. So client will get IP address of, can get instance 1 or instance 2 or instance 3, and it can send to any of the instance according to whatever the need that client is trying to get the functionality. All the 3 instances will give the functionality, but client decides which instance it is calling. So client is trying to do the load balancing. So it can send first 50 requests to the first instance, next 50 to the next instance, next 50 to the next instance, or it might send first to the first instance, second one to the second, third one to the third, and then fourth one to the first, like a round robin fashion. It will decide the load balancing pattern. The client will decide. Disadvantage, so the implementation of this, getting the data from the service registry, sending the API to the particular service instance, or doing the load balancing, all this logic you need to implement in your client. This is an extra burden. What is the other option that we have? Server side. So in this option, there will be an extra service, or existing service also can take care. The service can be a proxy or load balancer or router or gateway. So that takes care of talking to the service registry, getting the required information, and routing the calls to the respective service instance. So the client will make a call to the service, and this component, either router or LB or proxy, will take care of routing that request to the instance of the service. It can send to instance 1, instance 2, or instance 3. The client does not aware of which service instance is returning the response. The client only makes a call to this third party instance, mentioning that I need this service from this, I need this request to be processed by this service. Now this third party component will go and check, fetch the IP addresses of these services, service instances, and based on the load balancing load on all these 3 instances, it might route it to one of the instances. So and it need not always go and fetch the data from the service registry. It can have some internal cache also, but that cache needs to be updated on real time whenever there is a change in the service registry entries. So the advantages and disadvantages of this method is, there is no burden on the client side with this method. Your client need not implement. Client can be implement its own logic. It does not bother about how and how many services are there, how to do the load balancing, how to fetch the IP addresses. All this is shifted to the third party service. But as a regular practice, we need to maintain this extra service. This is a disadvantage with this. Who is going to use this? Amazon Load Balancer and Kubernetes internally maintains this kind of server side service, which takes care of this routing, load balancing. And Nginx also does uses this option with using one of the file, and that file will be updated at regular intervals.